So, okay, here we go. All right. So, ladies and gentlemen, so what we're doing here, it's still hypothesis testing, but it's almost like you're getting to the point where things are really, really, I would say personally, kind of interesting. And you might say, what do you mean they're interesting? Well, I don't know. It's when we start to compare two distinct groups. You're really comparing two distinct populations, okay? So you might say, I have population number what? 1, and I have population number 2. So this is really getting to the point, and this is why I say I make it take home. Only because of that reason is like I want to be able to talk about these ideas with you guys. So we're like comparing two distinct. You can see that word, and you can say distinct or mutually exclusive. So here's kind of what I mean by that, right? We very much like to compare who? Men versus who? Women. Okay, isn't that one place where we like to compare different groups of people? Men and women? Right? Who's more likely to smoke? Notice the language I use. More likely. Oh my God, what is more likely associated with? If I say more likely, let's note. Likelihood. What is that associated with? What is that letter? Likelihood. Isn't that a probability or a proportion? Right? Percent? So what parameter is that is what I'm getting at. Parameter P. Okay? Estimation calls that a true proportion. Hypothesis testing just says proportion. So that's what we're talking about. We're going to compare proportions today. This is why I say hypothesis testing for 2. The book calls that independent proportions. Oh, whatever. What they kind of mean is two mutually exclusive groups, men versus women, okay? You can't be both. You're either a man or a woman, but not both with this. So we might want to say, hey, guess what? Which population tends to smoke? Men or who? Or women? Which population tends to drink? Men or who? Women. Which population? Oh, what? What else can we say? What kind of things are you guys interested in between two populations? Anything? Okay. You're interested in that. I know. I've tried to stay away from that discussion because you never know how mature a class is. And sometimes, like in the morning class, when that topic came up, some poor kid in the room, he's like, oh, my girlfriend cheated on me this weekend. You always touch a nerve. Huh? Yeah, who's more likely to complete a 4-year degree, men or women, But yeah, who's more likely to cheat, men or women? Is it equal? I like the phrases you guys are using, equal, because we're going to see these phrases. We're going to see equal is the same as. We're going to see is not the same as, not equal. Those are all extremely important phrases in hypothesis testing. There's almost like the foundational phrases, is the same as. So you can start, okay, Snodgrass again has a claim, right, a hypothesis that men and women cheat at the same rate, equal, same. So in that case, right? If you say same rate, and I'll give you guys some of this language here. P1 equals what? P2. Because what does this word mean here, right? This is what? Equals, we say same. Is that right? And if we're talking about cheating, what do you guys think? Are the rates the same? Or are they different? Notice my language. The cheating, the infidelity. Some people are interested in that. That's okay. If you're a psychology major, you're probably interested in this stuff. Same. What's this phrase? Not the same. Okay. What else do we say for the same? We probably also mean what? Different. Is that right? So when we're comparing two proportions, very often you'll see some of these phrases. Do you know what phrase you can see for the same? It's kind of an interesting phrase. The phrase is not different. If you say you're not different, then you're saying you are what? You're the same. You guys see these phrases here. These are the key phrases we care about. Same, not the same, different. You guys with me on this? We're comparing. So even if you think of infidelity, who's more likely to cheat, men or women? Well, you know, and then another observation or a comment that was made by the earlier class is, well, you know, what do you guys think from your experience? Let's ask you. I know Jerry Springer, he passed away, but who's more likely to cheat, men or women? Men. 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 I don't. That's not a strong men. Is there anybody here that thinks it's women? Should we conduct a survey? Yes. In the room. I'm going to check you ladies. Any of you ladies here cheat? No. Raise your hand high and proud. No ladies? Okay, any of the men cheat? Okay. There's kind of a very interesting, historically, there's something interesting about this. This has always been a problematic kind of survey. Do you guys know why it's problematic? Well, it's generally believed that women, even if women have cheated, they don't even want to admit they have even on a survey. So it's hard to get data on that. Even on a survey, they'll put no. And they will forget, you know, what they've done. Men may be less likely. They'll, okay, yeah, I cheated. Okay, so it's always historically been a very difficult thing to gather data on, just by the way, just so you guys know. But it is generally believed that women cheat just as much as who? Men. Maybe even more. People go, I don't believe it. Once upon a time, ladies and gentlemen, there was a law that they were going to pass in regards to newborn babies years ago. They were going to test the father, genetically test the father of every newborn baby that was born. And there was a lot of opposition to that law. What do you guys think? Does that sound like a pretty good law to have? I think it's great. I go, oh, yes, please do. Yes. I vote yay on that law. It didn't, they had a hard time getting that, you know, even creating the law. Do you guys know why they did? Why was it so difficult to even, I don't even think it was a law but they were trying to propose this creation of a law. It had a lot of resistance. Why do you think it had resistance? Huh? Because why? What's that? What's that? No, but why was that law had a lot of resistance that it got to the point where they didn't even draft it? People fought it. Why? Well, the reason they gave was people felt that's no way to start a life. Well, that was the reason. So if you're a man and you give you're with somebody, whatever you're married or not married, if that woman says you're the father, and you're responsible and accountable, and that's the way it is. And they didn't want to change that. Not it wasn't because you think it was those reasons. That was no way to start a life. So it's kind of interesting. But through history and time, believe me, if you guys are pretty much awake and you look around and you listen, there's always in that family that one kid that got treated different. You're like, why is that kid treated so different? You guys know what I mean? There's reasons, ladies and gentlemen. Just throwing that out there. There's reasons. So, I think that's all I'm going to say about that. But now that I got your attention and you care about comparing two proportions, let me give you another phrase. P1 is more likely than P2. Proportions, probabilities. What's this about? What's more likely? How do you represent this phrase? There you go. Okay, you guys okay with that? P1 is what? Less likely than P2. How do I describe this? You guys know? What do you guys think? Is that easy peasy? See these words? Okay, you guys okay with these kind of phrases? What do you think? Not so bad? It's really not that bad, but you do have to understand this fundamental relationship. And you're comparing two proportions. Okay? So let's go to my notes. And you go, oh, Mr. Judge, they're calling those things two independent proportions? Yeah, they're mutually exclusive groups. You can talk about men versus women. You can even talk about, if I go back here to our group thing, you can compare even people based on, you can compare boys versus who? Girls. I'll put it down here. Nope. You can compare Hispanic versus non-Hispanic. Okay, you can compare Hispanic versus white if you want. It doesn't matter. You can compare men under 50 versus, men over 50. And I'm going to use the words, okay? Men over 50 with men under 50. or let's say men under 28. So there's a lot of different ways we can go with this. Okay, you guys see the difference? Two independent groups. So as you guys can see, this thing could get very interesting very fast by comparing groups of people with a lot of different scenarios, and it's used all the time. Okay, so here's the language I put as like kind of a summary in those notes. Proportions are the same. Proportions are not different. P1 equals P2. Proportions are not the same. Proportions are different. P1 not equal to P2. P1 is more likely than P2. P1 is less likely. P1 is no more than P2. P1 is at least P2. So these are kind of the standard phrases that you guys see with language in comparing two proportions. The first two are the big ones because we like to see and assume that people are the same in some way or groups are the same, but they're not. Sometimes we say they're different. Okay, so these are kind of where it starts, I should say. And what you guys see here in the notes is the exact same hypothesis testing procedure. It's exactly the same. So part of this is what is new and part of it is what? Old. So that's good, that's bad. I should say it's good and good, not bad. It's good because you go, oh, I get to see the hypothesis testing procedure again. I'm going to need it. Yes, you are. Notice this. When you look at the alternate hypothesis and it's not equal, that's always a what? Two-tailed test. Is that right? Greater than is always a what? Right-tailed test. You guys see what I'm saying? So some of you guys may not even know that because I get communication all weekend going, Mr. Judge, how do I know it's a two-tailed test? How do we know that's a left-tailed test? It's pointing to the left. Good job. The alternate hypothesis inequality. And so if you ever notice, it's a null hypothesis when it involves a condition of equality. That's why you see the equal signs for the null. And it's an alternate when it does not involve a condition of equality. Didn't we talk about those things? Yes, we did. And this is our alpha. It's on the tail. And then this is what? Half alpha because there's two tails. This is all review, ladies and gentlemen. But when I was talking to students earlier before class started, it was a remark that it seems to me since AB 1705, there seems to be a lot more. What is it? What was the remark? I already forgot. See, I'm an old man. Procrastination. Yes, there's a lot more. Generally, there was procrastination, but there's much more due to these bills. That's my observation. There's more. It's going to be interesting. I'm going to see. This is when at the end of the semester I do my own analysis after action, and I think about okay, what was the situation? What went on? Why? What could I do different, if anything? You know. But it's interesting. Always label the hypothesis. That's the what? That's the claim. Haven't we been doing that? So if you're really up to date with what we're doing, you're going to say, "Oh, Mr. Judge, this is easy breezy," and it is. It really is. It's not as hard as you guys think. In the old days, we used to have to use these formulas for our test statistic. So I'm keeping this stuff for nostalgic sake. I'm not going to get rid of it, because I want to keep this stuff. But in the old days, these are how we computed test statistics. And then step 5 was your conclusion. So it's the same exact process, but the test statistic, we use what again now? What do we use? TI. And I can even tell you now in the TI what you use. Okay? So here's really a couple of notes for the TI before we dive into it. Note. The test statistic, well, it's going to be The test statistic is going to be what we call, two proportion to what? Proportion Z test. I wonder why they call it two proportion Z test. Because it's a what? Two proportions. The critical value you use inverse norm. Okay? And that is the only difference. This is the only difference, ladies and gentlemen. Okay, you guys okay with that? We're going to dive into it now. We're going to look at some examples. That's the only difference. Yes, in the old days, we had to use the Z table. Not anymore. We use the T inverse norm. Now, let's do a deep dive. What do you guys think? You guys ready for this? Okay, let's try this out. I'm just kind of curious. I'm going to ask you guys a question. Don't read that one yet. Okay, you guys can read it. It's fine. If I ask you guys this question, I kind of want to know. We don't have to talk about infidelity because you guys know. Don't want to turn it into the Jerry Springer show. You don't want people crying in the room. I don't want you visiting me in my office hours telling me your story. You guys know what I mean? I don't want to hear it. Cheating and all that stuff. But how about this? I'd rather hear this. Who's more likely to believe in ghosts, men or women? I don't know. What do you think? Who's more likely to believe in ghosts? Women? Why would you say women? They're more what? They have more intuition? They're more intuitive? Any ladies here any ladies not believe in ghosts? You don't believe in ghosts? Okay, that's fine. Where are the ladies that believe in ghosts? I already know one story. You ever see a ghost?
I told you my story.
Okay, I'm an old man. I forget. I don't even remember my name sometimes.
Just doors in my house slam.
Oh, the door slam.
Yeah. And there used to be like a wheelchair lift.
That's right.
Took it out.
That's right. Doesn't happen anymore? It still happens?
Yeah.
What's your mom and dad say?
They got an exorcist when they moved into the house.
And what happened then?
Well, my mom says it's gone.
Oh, she says it's gone. Is it gone?
Who knows?
Interesting. Good. They called in an exorcist?
Mm-hmm. Like
Catholic priest?
That's it.
Okay. Well, maybe then we should just talk about smoking. How's that? Okay. Sorry, I'm eating my Starburst. I shouldn't be, but I am. A study was conducted to determine the college student gender was more likely to smoke. Okay. Let's read this. Any of you ladies here smoke? Any ladies here smoke? Where are the smoking ladies? Maybe they're in the morning class. We got one. Does that help you out in any way?
I don't do it as frequently as before. It was just kind of like the rest of my family smoked, so it's kind of, I was exposed to it at a young age, so I'm trying to like cut that.
Okay. The proportion of female college students who smoke is what? Less than. Let's write this down. Proportion of female who smoke is less than what? Proportion of male students who smoke. As what? As claimed by good old Snodgrass again. So what would you guys write down? You can say PF less than PM or P1 less than P2, but you want to know female and male, and is this the claim? How do you know it's the claim? Because they say as claimed by Snodgrass. Okay, you guys okay with that? You guys see how that's kind of like a review? That's the claim, ladies and gentlemen. Let's see if you're really awake. I did what I did for a reason. I didn't tell you guys you're going to have a take-home test. I wanted you to study. I wanted you to not sleep last night. I wanted you to work on this so that you know what you're doing. I wanted you to be up to date. It's yes. I sometimes have to sneak the vegetables in the what? In the mashed potatoes. Sneak the peas. Yes. That's how I got my daughter to eat peas. I used to have to sneak it in her mashed potatoes. I didn't make up the phrase. I don't know where I got it, but I had to sneak the peas in the mashed potatoes so little Ashley can eat her vegetables. So I just did to you guys. I put the peas in. Now, is this a null? Let's see if it worked. Is it a null or is it an alternate? Good. How do you know it's an alternate? Good job. You see what I mean? What's the opposite of this statement here? P1 greater than P2. That's a logical opposite. You guys okay with that? So this is how you start this off. Okay. Let's ask you guys. Is this a left tail test, a right tail test, or a two tail test? Good job. Look at that. It's a left tail test. So I draw a left tail. Is that true? Okay, draw a left tail. Now, what do I label the non-shaded region? Always do not what? Don't reject your null. Over here, you're going to do what? Reject the null. Now, we need, what goes down here? What's that called? Good job. You need a critical value. How do you get it? You first need what? Well, no, we need this language. What's this language? The 10% level of what? So what does that actually mean? That means 10% is in this table, is in this tail, sorry. Okay. Now remember, this is a Z distribution. And because it's a Z, how you get your critical values is going to be that function called inverse what? Norm. Okay. Inverse norm. Now, I'm going to leave this up here because this is kind of where I have a student in the earlier class. He says he has the old calculator and he doesn't want to know how to use inverse norm. The default. Do you guys remember the default method? What's the default for inverse norm? What is it? It's area to the left of your what? Critical value. Area to the left was the default. Remember this? So this is what I'm saying. What we would do is say, hey, this is the default for those of you guys that have those. Is that right? It's area to the left of this critical value. What is the area to the left of that critical value? You're looking at it. It's what? It's 10%. It's your alpha, isn't it? What do you guys think? Is that easy? Did you guys study that this weekend? I hope. Nice. That Mr. Judge, he's like, wow. He made you eat your vegetables, right? Second distribution, inverse what? Norm. 0.10, that's the 10%. It doesn't give you the option of saying area to the left, so what is this? And that, ladies and gentlemen, is your what? Critical value. What do you guys think? Okay? Told you guys this was easy. What do you guys think? Is that okay? Not too bad. You guys could do this. All right. Now what do we do? We're going to have two samples. I didn't say that to you guys earlier, but if I go back to the notes, remember this? Two population parameter values. You're going to have a P1 versus a P2. You're going to have to now take a what? Sample. You're going to have to take a sample. There's going to be two samples. You got sample 1, and then you have sample number what? 2. You guys okay with that? You got two samples here. So when you take two samples, I want you guys to know you're going to have sample size 1, number of successes 1, sample size 2, number of successes 2, N1, N2, X1, X2. Okay, and this comes from your sample. So when you go back and read this question, you say, okay, let's read this. I'll put sample information up here since I'm up here. Sample 1, remember, this is going to be the females. Sample 2, this is going to be the males, or men. So what does the sample information say? What does it say? A sample of what? 1,200 female college students reveal that what? 228 smoke. This is X, and this is what? N. So N is 1,200. What is X? 228. Okay, is that easy? Okay, what does this say? 1,500 male college students reveal that what? 461 smoke. So this is what? And what is this? X. So 1,500 male students smoke. How many sample size. How many successes? 461. So, ladies and gentlemen, yes, you're going to have to go back and read that information, okay? Because you might say, well, what do I do with all of that? Well, what you guys do, and by the way, here are the notes. Okay? I left this in your notes. Isn't that how we got the critical value? All right, that's in your notes. What do you guys think? Is that okay? Is that going to be in the New York Times bestseller list, maybe? Oh, and then guess what I did in the notes? 2 proportion what? Z-test. All right. So this is where we're at. It's even in the notes. We're going to have to enter this in the TI. So do you want to do the old TI still, or you want a new TI? Old? Stat, test, 2 proportion number 6, Z-test. All right. What's the first successes? 228. What was the sample size? 1200. Okay. Second successes is what? What's the sample size? What kind of test is this? Is it a two-tail test? Left tail or right tail? Is that a left tail or right tail? Good. You may have to go back and take a look. Oh, that's a left tail. Left tail. Okay. So hit left tail. Now do what? Calculate. Okay. Now, what am I looking for, ladies and gentlemen? I'm looking for, remember, if this is a traditional hypothesis test, traditional, what do I need? The test statistic value, right? It's the Z value. Which one is it? Which one? Yeah, which one is it? The second value, what is it? Negative 6.95 to the nearest tenths? So this is my test statistic. And where does that live? Is that to the left of the critical value? Yeah, it's very much to the left, right? Negative 6.95. Okay, it's really to the left, by the way. Is that right? It's to the left of negative 1.28. Which neighborhood is this in? You're going to reject the null. What does that mean, to reject the null? You say, Mr. Judge, if you reject the first person thinking of cheating, you have to what? Accept the second person. The second person happens to be the what? The claim. So you reject the null to accept the claim. What's your conclusion? What do you guys say? The sample what? Good job. Supports the claim. How do you guys know the sample supports the claim? Because you just embrace the what? The claim. You're accepting the claim. Happens to be the alternate. So if you circle the claim, the sample supports the claim. If you cross out the claim, the sample what? Does not support the claim. Is that easy peasy? What do you guys think? That's your first two parameter or two proportion test. Is that okay? What if they want the modern method? The p-value method. What's your p-value? Do you guys remember? Oh, look at this. P-value, is it 1.85? No, it's actually approximately 0 to the nearest hundreds. Why? That's scientific notation. That means move the decimal how? 12 spaces to the left. That's a lot of zeros. That's 11 zeros in front of the 1. That's really close to what? 0. Now, so my p-value, this is the p-value. So maybe I should label just in case, okay? You guys want to test what? Statistic, because people are going to ask that. What is that number? It's a test statistic. What is this? The p-value. Why do you want to get the p-value? What do you actually have to check? If the p-value is less than the level of significance, right? Because what do we know? 0, 0 is less than the 10%. Remember we compared this the other day, thinking of money? Do you guys remember that? Isn't it true? The p-value of 0, 0, that's like nothing being broke, is smaller than a dime. Then what was the conclusion if you had that? What did you automatically do? You accepted the what? Alternate. Yes. So if you had that criteria, and we do, we accept the alternate. Now, isn't that exactly what we just did? We accepted the alternate. We embraced the alternate, which happened to be the claim, which means what? Sample supports the claim. So, ladies and gentlemen, there you guys go. This is how we start to do this. What do you think? Is that impossible? You guys like comparing two proportions? What do you guys think? Do men smoke? Well, what is that? What does it even mean? What was that? What group? Oh, females. Yeah. So what the sample is suggesting, the proportion of females who smoke is smaller than the proportion of males who smoke. Now, I have no idea. I have no idea. I don't know anything about smoking. Don't know if it's true. What do you guys think about that? Pretty good? And your notes are there too. Okay, let's go to the next example here. How about this? Fast food order accuracy. You guys order fast food? Does it drive you crazy when they make a mistake on your order? I know I hate it. Woo! Hate that. What does this say? In a study of Burger King drive-thru orders, it was found that 285 orders were accurate and 36 orders were not accurate. This is from BK. Okay. What else does it say? For McDonald's, it was found that 332 orders were accurate and 52 were not accurate. Okay. Use, what do they want us to use? Use the 5% level of significance. What is this? Alpha. What do I do with the 5% level of significance? I what? Test the claim. What's the claim? That Burger King and what? McDonald's have what? Different accuracy rates. What? What does it mean to have different accuracy rates? Yeah, what does different mean? Not the same, not equal. Is that right? So what do we write down then? We can say probability of B of, what was the first one? Burger King. We can say P of what? B is not equal to P of M. Is that true? Or we can say P1 not equal to P2. Doesn't matter. Now, this is the what? Always write that down. That's your claim. Write it down, okay? So now, let's see if you guys are awake with this. Where does that belong? Is that a null or is that an alternate? Does that go on top or bottom? Bottom. Why? Does not involve a condition of what? Equality. What's the opposite of the not equal? Equal. Okay, so here's my alternate hypothesis, and it's not equal. What does that mean? To what? Tail test. So draw a bow with what? Two tails. Okay, so what do we say? We say what? Do not Reject the null. And what is this? You're going to reject the null. I need what again? Two what? Two critical values. Okay, you guys see what I'm saying? You guys see this here? Okay, now here's what we're going to do. Alpha is 5%. Is that right? So where does that go? If there's two tails, how much is in each tail? 2.5% here and what? 2.5%. And 2.5% is 0.25. Is that right? Okay. So what do we use to get the critical value? Go to the left here, inverse norm. We're going to use the default in honor of those students that have the what? The other calculator, the older TI. In honor of them, we're going to honor them. Okay. Second distribution, inverse norm, 0.025. Remember, area to the left of that leftmost critical value. What do you got? Negative what? Negative 1.96 to the nearest hundredth position. So this is going to be negative 1.96. But there's two critical values, positive 1.96. Make sure you put both critical values in your two-tailed test. Okay, you guys okay with that? All right. And of course, I went through the information for you guys there in the notes. And we're going to now have to use what again? The two proportion what? Z-test, but we need two samples. So I have to go back and get two samples here. Where's the sample information? I apologize. We have to read. Is that right? Now let's be careful here. So for the sample information, this is the first group. Sample for the second group. What's the first group again? BK. Which is better, BK or Mickey D's? Huh? You guys like Mickey D's or BK? Let's read this. At BK drive-through, it was found that what? 285 orders were accurate and 36 orders were not accurate. What does that mean? If we're looking for an accuracy rate, what is your successes? What are the successes if you're looking for an accuracy rate? The orders that were accurate. Is that true? Okay. But then what's the sample size? Anybody know? What's your sample size? Isn't it 285 plus what? 36. So you might say, boy, Mr. Judge, weren't they pretty sneaky? They were sneaky. How do we know they're sneaky? They gave you the number of orders that were accurate and the number that were not. You have to add those. What does that equal? Let's see. 285 plus what? 36. What does that equal? 321 orders. Okay. So I need the 285 and I need the what? 321. 321. Oh, they're a little sneaky. Okay. Now, what about Mickey D's? 332 orders were accurate. 52 were not accurate. This is an accuracy rate. So we need the number of orders that were accurate at Mickey D's, and they're saying how many? 332. But the sample size is the number who are accurate plus the number that are not accurate, which is how many are not accurate. How many are not accurate at Mickey D's? 52. I wonder what that total is. 332 plus 52. I don't have to use a calculator. I think that's 380 what? 4. Can you guys do that arithmetic? 332 plus 52, that's 380 plus 4, 384. Okay, what do we look for, ladies and gentlemen? Two proportion what? Z-test. So we're going to enter the sample information into a two proportion Z-test. So let's try it out, okay? That's what we're going to enter. It's in the notes even. Stat. What's this? Test. Two proportion Z-test. Okay. Successes. 285. Sample size. 321. Successes for the second group. 332. Sample size. 384. I forgot. What kind of test is this? See, I already forgot. Old man judge forgot. Was it a two-tail test? Okay, two-tail. Hit enter. And then hit calculate. Okay, let's verify this. What's your test statistic value, ladies and gentlemen, to the nearest, all right, whatever, nearest thousands, I guess. What is it? 0.931? What's your p-value? Is that 0.35? Is that what I have in the summary right here? Isn't this my p-value? Right? You guys see it? Okay. Where's 0.93 in your decision rule? What do you guys think? Where's 0.93? Mm-hmm. Isn't it like somewhere here between? Isn't it right in the between 0 and 1.96? Do not what? What does that mean, to not reject? Don't reject the no. You what? Accept the no. But you're not going to cheat. You can only have one. What did you just do? If you accepted the no, you rejected the alternate. What did the alternate happen to be? The claim. So what do you say? The sample does not. Support the claim. And you say, why? Because you crossed out the claim. So this suggests that the accuracy rates are the same. They're equal. Go back. Remember the p-value? Your p-value up here, 0.35, really 0.35, is not less than 5%. That's like 35%. And that is not less than So do you guys remember what we said? If it's not less than, you automatically accept the what? The null hypothesis? Automatically accept the null. Did we do that? We sure did. The conclusion's the same, though. Sample does not support the claim. What do you guys think? Not too bad? This is, like I said, it's a very powerful test because we care about proportions being the same and different. How about this? Anybody here dream? Who here has dreams? Can I ask you guys, when you dream, is it in black and white or is it in color? It's in color? Really? I don't even dream. What does that mean? Does it mean you're a deep sleeper if you don't remember your dream? Really? Are you sure? I thought it means you're a light sleeper. Well, I don't know. I don't know. I hardly ever dream. Yes. Ironically. I went to the doctor on what day did they say I had to go to the doctor? Maybe I didn't tell you guys. Last week I went. What days? I went to 2 doctors. Anyway, well, I told the doctor, "Hey, doctor, I don't sleep. I don't dream. You know, blah blah blah. I have my CPAP machine and keeps me up. And man, because the doctor says, what's been bothering you? Oh, my shoulders. I'm kind of weak shoulders. I don't know what's going on with my shoulders. Hope I don't get in a fight because my shoulders feel a little weak." He says, "Well, we may have to check your testosterone level." I said, "Okay, please do." And then he said, "Take some magnesium to get to sleep." You could take melatonin, but he finds magnesium also works well. Anybody hear about that? Magnesium? First I ever heard. I don't know. I went in GNC and I got super magnesium. I don't know, but I asked the guy, "What's this super magnesium stuff?" He goes, "Oh, extra absorption. That's what I need. Extra absorption of magnesium. I want to dream." You know what the irony was? That night I dreamt. I was like, "Wow." It's a weird dream, though. I can't say. I can't say. We're trying to keep the Jerry Springer out of this. Trying to keep Jerry Springer out of the lectures. It involved infidelity.
So was it a nightmare or a dream?
It was kind of a nightmare. I guess that's all I could say. I hope my wife's not listening. Is she online? Is she online? I don't even tell her. I won't tell her my dreams. You don't tell that stuff to your wife, do you? Hey, honey, I had a dream. Oh, no, you never do that. If you're smart, you don't. Don't even go there. She'll fight with you even if it's a dream. That's what I say, but tell that to a wife. It's my what? Oh, shoot, that's what she. Oh my God! I better stop. I better stop now. But I remember it. That's kind of odd because it has to be years since I've dreamt and I really remember the dream that vividly. Weird. I blame it on the super magnesium. I'm taking it every night. So that doctor is right, man. Anyway, this is true stuff. I'm not making this stuff up. That these are things that people do research on. So if you're a psychology major, you might care about this. They care. Psychology people care about a lot of weird things, don't they? Like infidelity and dreams. And did you dream about infidelity? You know what I mean? I wonder what it means. A study was conducted to determine the proportion of people who dream in black and white as opposed to color. Among I don't know what that was. Among 400 people over the age of 50, 68 dream in black and white. Among 275 people below the age of 28, 22 dream in black and white. Okay, now we're getting somewhere. Use the 10% level of significance What do I do with that 10%? I test the what? The claim that what? Here it comes. Here comes the claim. The proportion of people over 50 who dream in black and white is what? Is different? What does different mean? Not equal. Is different than the proportion of people below 28 who dream in black and white. All right. Okay. What do I know? What does this mean? P1 is not the same as P2, and that is the claim. Now, ladies and gentlemen, the first group are people over what? 50. The second group are people that are under what? 28. So they're saying that these proportions are not the same. That's all, that they're not the same. So they're trying to really determine whether age is a factor in whether you dream in black and white or not. What do you guys think? Might it be a factor? I don't know. All I know is I don't ever remember dreaming in color. I know, isn't that sad? It's weird, isn't it? But you guys know a greater proportion of men are also colorblind than women. That's why our clothes don't match. It's not taste. We just can't see the colors very well.
Wasn't it the women, their eyes were developed to see more range of color?
I have no idea. Why would they want to see more color?
I think because the biological theory was that in the past they were gatherers. So
Interesting.
Berries or certain things that were
There might be something to that. There might be something to that. So you ladies were gatherers, so you're genetically programmed to see better. Berries versus what? Maybe the poisonous berries over the edible berries. I don't know. Interesting idea. What about men? Since they were the hunters, I assume. What do they come with? Bigger shoulders? What do you guys think? Stronger shoulders? Except for me. Getting weaker. My shoulders. I'm going to have to. I can still feel it now. It's like, what the hell? Could be what? Tension? No, I was actually, about a couple of months ago, this is true. I was lifting some like cabinets. Let's just put it that way. Some things that I used to always lift, putting it over my head and everything, carrying a lot of things I used to carry without a problem. The next day, I couldn't even lift my arm. I was like, what? I know I strained myself because I was pushing myself, but I couldn't lift my arm. And that was months ago. Now I haven't really gotten my strength back. I have no idea. Where does this hypothesis go? Is it a null or is it an alternate? Why? Yep, not equal. Lack a condition of equality. This is P1 equals P2. So, ladies and gentlemen, what do I do now? This is not equal, and this is H1. What do we do? Is this a two-tailed test? All right. Draw a picture of what? Two tails. Do not reject the null. What is this? Reject the null. What is alpha? What does that mean? 5% is in each tail. Is that right? So there's two tails, and you'll have two critical values. 0, Z. How do we get those critical values? You guys remember? We got to use the what? The default. Okay, second distribution, inverse norm. Point, what is that? 0.05, and then what? What is that Z value? Okay, and then what's the other one? Positive 1.645. There's two critical values, ladies and gentlemen. So we're doing this default in honor of those that have the older calculators, okay? Because, you know, some of those students contacted me this weekend going, hey, I can't do inverse norm. How do I do inverse norm? You guys know what I mean? Negative 1.645, positive 1.645. Those are my critical values. I'm going to have to take a sample. Is that right? Or two samples. So let's take our two samples. Let's read. Okay. What does it say? Among 400 people over the age 50, 68 dreamed in black and white. Okay, that was my successes. Is that true? What is the 400? And what is X? 68. So this is the older group. Can you smell in your dream? Do you guys smell too in your dream? Like if there's a rose in front of you, you can smell that rose in your dream? Oh, it's an interesting question. Just wondering. If someone's cooking like some spaghetti or something, can you smell it in your dream? In your dream, I'm talking in your dream. They're cooking spaghetti, you can smell it? If someone was mean to you, do you feel sad in your dream? Do you have emotions in your dream? I might become a psychology major. So why is it you can feel emotion and you can see, but you can't smell? Maybe you can. They're all senses. That's my point. I'm just throwing it out there. Sorry. Among 275 people below the age of 28, 22 dream in black and white. So N and X. So this is for the young group. Smaller sample size, 275. How many successes? 22, yeah. You can feel emotion in dreams. You can visualize a dream, even in color, but you can't Smell. It's kind of weird. What? What happened to my picture? My picture's not even there of what I got to do. Note to self. I got to fix this. Did you guys notice it? I just noticed it right now. Anyway, okay, let's enter this ourselves. Gosh, typo. Stat, test. Number 6, isn't it 2 proportion z-test? You guys okay with that? 2 proportion z-test. Now, all right, enter the data. How many successes for the old group? 68. What's the sample size? 400. How many successes for the next group? 22. What's the sample size? 275. Is this a two-tailed test? Is it? All right, hit calculate. What do we see? Looks like this is up. This is accurate. Because what does this mean? Task statistic. And then what's this? P-value. So what was our critical value? Was it to the nearest hundredths? I don't know. I should have did hundredths. Here's my summary. Task statistic and then my z-value, whatever. It's already up there. So let's do 3.380. 3.380 is a test statistic, ladies and gentlemen. Oh, where does that test statistic live? Is it to the right of your critical value? 3.380. This is that test statistic. So they're going to want to know that number. And what neighborhood does it live in? Because it's bigger than the critical value. You're in the reject the null region. Okay, you guys seen everything right there that you need. What do you guys think? Reject the null. So what do you do with that null? You say, null, where are you? You are what? Rejected. What are you going to accept? The alternate. What does that mean about your claim? The sample supports the claim. Easy peasy, lemon squeezy. What do you guys think? Not too bad. What do you guys think? Should I give you guys a break? What are you going to go do in the break? Sleep? Eat? You can go to Blaze Pizza and pick up a pizza? Should we give you guys a break? All right, we're going to give you guys a quick little break here. And we'll see what we do. Okay, here we go, ladies and gentlemen. A break. All right, ladies and gentlemen. You guys want to try one more of these? Let's try one more. No, not that one. Actually, well, that's kind of weird. Let's try this one here. Let's try a medical version because this is real stuff. This is real life stuff. This is what they do when they test medicines. And you want, like we said, this is a scientific method. You guys want to do this kind of stuff. Now, anybody know anything about aspirin and heart disease? What is it? Does it really prevent heart disease? I don't know. It thins your blood, but supposedly that's bad. So you're supposed to take baby aspirin, which is a lower dose. Anyway, whatever. We don't know, but here's a study on it. Okay. So, in a study designed to test the effectiveness of aspirin in preventing heart disease, take a look at this one. Look at the group. 12,000 male physicians were treated with aspirin, and 11,000 male physicians were treated with a placebo. Do you guys know what that means? Yeah, a placebo is like a sugar pill. It's a phony baloney pill. Okay. Now sometimes it's like they call it a blind test and a double blind test, meaning they don't tell them what they're taking. So they may tell the one group, hey, you guys got the aspirin, and the other group they might say, hey, you get the placebo. But if they blind the folks, they don't know what they're taking. So it's a way to test the effectiveness of any sort of medication or substance. Okay, so we want to do something like this because it's fascinating. Okay. Among the subjects in the aspirin group, 152 experienced heart attacks. Among the subjects with the placebos, 242 experienced heart attacks. Okay. Now, what do they say? Use the what? 5% level of significance. Okay. So the second I see 5%, what do I write down? I say alpha's what? And what are you going to do? You're going to what? You're going to test the claim. So here comes the claim. What's the claim? That aspirin has no effect in preventing heart attacks. Okay, so notice this. The claim is aspirin has no effect now in preventing heart attacks. So I went through and I did more because I edited this thing and I have to go back and fix the problems. That is, the heart attack rates are the same. So when they say they have no effect, what they're saying is this, that the heart attack rates are the same. That's the claim. Heart attack rates are the same. Okay, so what's the rate of a heart attack? What are the two groups? Yes. You got the aspirin folks versus the who? Placebo. And what does it mean to say they have the same heart attack rate? That it means equal. Is that right? So I wanted to go over this one as well. And I want to ask you guys, where does this go? Is that a null or is that an alternate? Okay, so I'm going to put it here so it fits. How do you know that's a null? The condition of equality. What's the opposite of that statement? Not equal. Is that right? Okay. What kind of test is this? This is a what? Is that a two-tailed test? Okay, you guys okay with that? That's going to be a two-tailed test. Is that right? So that's the real deal. Aspirin versus a what? Placebo. Okay. So what are you guys going to draw a picture of now? Okay, look at this here, ladies and gentlemen. That's a two-tailed test. So we say what? Do not reject the null. Is that right? This is the non-rejection region. And then over here, what is this? This is going to be our what? We're going to reject the null. What was the level of significance on this? 5%. Okay. So if there's two tails, 2.5% is in each. Is that right? And in honor of the folks that have the default calculator, the older, okay, we're going to get the critical value. All right. Okay. Second distribution, inverse norm, 0.025. Is that right? Okay. Negative 1 point what? Is that negative 1.96? Okay, you guys okay with that? Okay. So I have two critical values. I'm going to get rid of all this so it doesn't distract us. Okay, you guys okay with that? Pretty simple. So this is a very classic scenario. Placebo versus whatever, you're taking. Classic scientific method. This is behind a lot of medical experiments, what you're looking at right now. So I'm glad, like I said, this is why, with all my travels and the stuff I have to do there, and I missed some classes, I hated that, by the way. And if I didn't do that, we wouldn't have a take-home test, but whatever. Okay. Who cares? Huh? Yeah, I know. You're like... Anyway, okay, let's see what happened amongst the two groups. Okay, remember, what's the first group? The aspirin. What's the second group? Placebo. Okay, what does it say? 12,000 male physicians were treated with aspirin. Did you guys see that? So what's the sample size for that group? And notice how they did this. Then they said what? 11,000 male physicians were treated with placebo. So that's the other group. So they jumped groups with the sample size. Okay. Now what do they say? Okay, I'm going to have to really, I must have been sleepy. Among the subjects in the aspirin treatment group, what happened? 152 had heart attacks. This is the heart attack rate. This is successes. 152 had heart attacks. Okay. Amongst the subjects treated with a placebo, what's the deal with the placebo people? 242 had what? Heart attacks. Okay. What do you guys think? Pretty good? The aspirin and the placebo groups. Anyway. All right, here we go. Let's copy this. Or move it down. All right, so we're going to have to enter some information. What do you guys think? Two proportion z-test. You guys even see it right in here? What do you guys think? You guys like that? Would you buy this set of notes if it was on Barnes & Noble? Yeah. All right. Then I better edit it and fix the problems because... How do you market that stuff? Is there a way? Yeah, I don't know. How do you put it? Where do you put an offer up or something? I don't know. I got to figure this part out. Stat, test. I got to get to Maui. You guys know what I mean? Two proportions Z. I'm gonna try to meditate on that, think about it. Hopefully I dream about it. Sometimes you can dream on a solution. Did you ever do that before? I don't know. Okay, how many successes? I hate to say it, a heart attack was a success. 152 amongst the aspirin people. There are 12,000 sample size, and these are male physicians, by the way. So that's very particular. 252 male physicians who were given the placebo, 11,000. What kind of test is this? Was it a two-tail? Anybody remember? It was two-tail? Okay. All right, so let's see. Let's double check. Did we get the same answers? -5449. And yeah, I think we did. Okay, I think we did. Okay. So I'm going back here to emphasize a few things, right? Here's your test statistic. And then here's your, what color were we using? Blue, I think. P-value. The test statistics, -5.45. And then what do you guys know about the p-value? Isn't that about close to 0? Because don't forget what? Scientific notation. Times 10 to the -8. Okay, you okay with that? So where does this p-value, -5.45, this test statistic lives where on our decision rule? It's over here, is that right? -5.45, somewhere over here. That's the test statistic. Isn't that to the left of our critical value? We have two critical values. What neighborhood is that in? We're going to reject the null. You guys okay with that? We're rejecting the null. So you say, okay, no, goodbye, no. The null is gone. That means we accept the alternate. Is that true? What's our conclusion? Sample does not support the claim. You say, why doesn't the sample support the claim? Because you rejected the claim, happened to be the null. So double check, ladies and gentlemen, if I said to you, what about the p-value? Right? Our p-value is what again? It's approximately 0, isn't it? Why is the p-value approximately 0? Because that's scientific notation. You move the decimal 8 spaces to the left, means there's 7 zeros. What I put here in the summary, here, I actually put it right here. Here's my p-value. But that is approximately, if I go to the nearest what? Hundredths? That's approximately 0. Okay. Now, is it true that being broke is less than that level of significance alpha? Remember this statement here? Isn't that a true statement? Say yes, because we're trying to relate what? The p-value is less than the level of significance. What does that mean again? By the p-value method? Accept the alternate. That's an automatic accept the alternate situation. If you accept the alternate, go back up here. Here it is. You're accepting the alternate. Isn't that the same outcome by the traditional method? Aren't you concluding again? Sample does not what? Support the claim. Okay. All right, ladies and gentlemen. Let me also share with you hypothesis testing about two what means. Okay, so you might say, can you do the same exact thing, but for means? Yes. Now you say, where are those notes? Go back here. I'm going to kind of redo this web page, ladies and gentlemen. Statistics Online. That was the transition, but no, that was the days in which we were due to COVID. Okay, so I put that on the comment section for you guys. Okay, so now let's see, where are we at here? Where are we at? Darn it. There we go. So notice you have the same language. Is that right? I think I did import it. Yeah. Notice the language is the same. What do we mean by that? Now, this is going to be comparing two independent means. Mu1, mu2. Those are two means. Okay? So when they say the means are the same, well, what's the meaning of the same? They're saying the means are equal. Is that right? The phrase, the means are not different, by the way, is the same as saying they're equal. Isn't that weird? Not different. That's like saying not the same. That's a double negative. The means are not the same. Right here. Means they're different. So those are kind of the language that you guys can see sometimes. Okay, we just want to make sure you guys are clear with that. And then mu1 is more than mu2. Isn't that greater than, more than? Mu1 is what? Less than. We're looking at those phrases here. Okay, different, not equal, the same, equal. So I want to point out to you guys the phrase, and then no more than, mu1 is no more than mu2. You guys know that's less than or equal, and at least, oh my God, talk about the typos. Mu1 is at least, it's greater than or equal. So I'm going to keep this, and I'm going to have to fix that when I get home. Note to self. Okay. Now, what I want to remark to you guys is this. Again, it's the same exact format, the same thing. But yes, your test statistics are here what you guys see. And yes, technically, we're assuming the population standard deviation are unknown. And if that's the case, we have to use the t-table. Okay? So you might say, we using the t-table for this? Yes. Although you guys know we're not using the t-table, we're using the TI calculator, and we're using inverse what? Be careful. Is it inverse norm? What do you guys think? Be very careful. Inverse norm? Nope. Did you guys ever do hypothesis testing on a small sample? Yeah. For a mean, what do we use? Inverse what? T. So your critical values, ladies and gentlemen, this is one thing. For the critical values, you got to use inverse T. And if you're using inverse T, well, we're going to talk about that. The second you have a small sample, you have to use degree of freedom. Do you guys remember that thing? What's the degree of freedom formula? N minus 1. However, you're going to have 2 samples, though. So I'll explain to you guys this portion here. I just want to let you guys know. Critical value is going to involve inverse T. Here we go. Let's try this out. Age of college students. Female versus male. Who do you guys think is older for college students? Male or female? What do you guys think might be older? Well, what does it say? The mean age of female college students is what? So we're going to say the mean age of female. Oh, that's mu. Mu F, if you want to look at it that way, is not the same as the mean age of male college students. Okay, and that's mu M, if you want to look at it that way. And of course, this is claimed by who? Good old Snodgrass again, okay? So, not the same, isn't that not equal? Okay? So, this is the claim, ladies and gentlemen. You can say mu1 or mu female is not the same as mu male. Our claim. Okay? All right. Is that a null or is that an alternate? Where does that go? Alternate. Good. What's the logical opposite of that statement? Mu F equals. Good. Mu M. Okay, you guys okay with that? Now, of course, what kind of test is this? Two-tailed test. Do what? Not reject the null. And then what else do you do? You reject the what? No. Okay. So remember, this is going to be a T distribution. It's not going to be a Z distribution. So we did this here. However, here's what's going to happen, ladies and gentlemen. I want you to go back and read the sample, okay? Because here's the dilemma. Remember, what do you do to get critical values? Let me share with you guys the dilemma here, okay? Don't we need a degree of freedom? If I went to the calculator and I went to inverse T, I'm going to say second distribution inverse T. This is probably where some people are going to get really confused. Inverse T. We got to talk about this. How do we get our critical values? We need an area, we need a degree of freedom, and we need to paste that. We just need two numbers. So when you go over here, I share with you guys how to find and use inverse t. If you guys remember last time, it is always what? Area to the what? To the left of what? Yeah, the rightmost critical value. Okay. So you might say, what in the world is that? Okay. Since there's two critical values, evidently, what is alpha? We didn't read that, but let's read it. Alpha is what here? Alpha is 5%. Is that right? So let's kind of continue with that. Alpha is 5%. But if we have two tails, you guys know the drill. What does that mean? 2.5% and what? 2.5%. So let me express this to you guys here. This is for inverse t. This is area to the left of the rightmost critical value. Would you guys agree with that? You want to know what you need to know? What area is right here? If alpha is 5%. Good job. Isn't that 95%? So when they have that area value, I take 95 plus 2.5. And isn't that going to be what? 97.5, ladies and gentlemen? This is what you got to do. Yes.
So just to clarify, you use inverse t with two means?
Yes.
But when we're going back to the singular mean, it's only for small samples, right?
That's correct. Yes. Yes. Yeah. And also, Tree, I'll show you in a little bit. I have a little. I have a summary sheet that I give people for their testing purposes. Okay, just so you guys know. If you say, "Where do I get that little summary sheet?" Right here. So if you forget and you go, "Mr. Judge, I'm on a test," because your point is a good point. I actually see this here. Estimating a mean small sample, t interval. Where is it at? Inverse norm, hypothesizing about a proportion. I tell you guys how to get the critical value. Hypothesizing about a mean large sample, inverse norm, critical value. Hypothesizing about a mean small sample, inverse t. Okay. Hypothesizing about two proportions, inverse norm, two proportion z-test. And then this one, which is what? Hypothesizing about two independent means, inverse t, two sample t-test. So T and T, two sample t-tests, T. So I keep that there for you guys just in case, okay? Just want to make that clear. And this is I don't think I told you guys, but another student in class, I thought of, remember I said I do an after sort of action thought process for myself. I might do a separate kind of worksheet about inverse T and inverse norm. I don't know.
For inverse t, are we supposed to do the area to the left even if we have the old calculator? So that entire.
Well, I'm doing the old right now because some people have it and then they kind of go, "Oh my God, I don't know what to do." If you have the new, we can see what it is. If it's new, then it might not be. I don't know. I'll see what the new thing is.
So it's the entire area to the left.
To the left of the rightmost critical value. It's kind of, you know what I mean? The instructions are there. This is the rightmost. I know. If I was the programmer, I wouldn't have done that. I would have been consistent with inverse norm and inverse t. But they're programmers. They're not mathematicians. You guys know what I mean? Note to programmer. Hey, why don't you just be consistent? Make it like the inverse norm. It's not like it's a problem. You know what I mean? It's a program doing it. You guys, come on. But these are the older TIs. So I don't know what the deal was. The newer TIs, I don't think have that. But I'll double check. I did put it in the notes though. So this is why you see, hey, Mr. Judge, 0.975 for the area. Yeah, because that's how they defined it. But then notice what's the degree of freedom? And it's the degree of freedom of the what? The smallest sample size. You're going to have 2 samples. So let's see why it's 44. If you look at the sample information, okay, what's the sample information? You go, sample information, let's read. A sample of what? 45 female college students reveal a mean age of what? 24.8 and a standard deviation of 3.6. So because it's a different parameter, okay, sample size is going to be what? 45. Sample mean is going to be what? 24.8. A sample standard deviation they're saying is what? 3.6. The second sample, it's a sample of what? 85 male college students, a mean age of 26.9, and a standard deviation of 2.6. So now 85, mean 26.9. What's the standard deviation? 2.6. So notice this. The degree of freedom they want you to use is 45 minus 1, which is 44. Why? Why is that, ladies and gentlemen? Because what was smaller? 45 versus the what? 85. So there's only one number you're going to use. It's the smallest sample. So that's why it's 44. So if you look at the instructions, you go, oh, okay, inverse T. I just followed, ladies and gentlemen, the instructions that I'm saying to you.
So is the degree freedom
It's 1 minus the smallest sample size. So you say, which one's smaller, 45 or 88? 45. So this is going to give you your critical values. So what I did here is I entered that in there for you guys. Critical value is 2.02 to the nearest hundredths. So this is what I did. We're going to do it together. So it looks like, Hannah, that's really what's in the old. See, that's a newer picture. 975, and this degree of freedom is what? 44. Okay, so I'm showing people second distribution, inverse T. And 0.975 and degree of freedom 44. We should get 2.02 to the nearest hundredths, and that's exactly what it is on this sheet of notes. 2 critical values. So this is new for you, and it's really about hypothesis testing about 2 means, and they're independent, whatever. See, there's other tests that you guys can have. In all honesty, there's a lot of other tests that can exist. But if you said, oh, that's already enough, it is, but it is. 2 sample what? T-test. Now you say, why T? Because it's 2 means. Okay, so just kind of throw that out there. And again, if you say, what's the real technical point? The real technical point is that the population standard deviations are unknown, which is realistic. So that's why I use the S. Anyway, you're going to enter this information here from the sample. So we already wrote down sample information right up here. Oh, what happened? Right here. So we're going to enter this into the two sample t-test. Two sample t-test. Two sample t-test here. No, be careful. Be careful here. I want you guys to note, be very careful. Let's note. Note. This is comparing to what? Mu1, mu2. It doesn't matter what the sample size is. The assumption, here's where the real assumption is. This and this are unknown. That's where the real assumption is, which is a valid assumption. So anyway, and that's what I'm going to give you. It's not going to be, I got you. They're known. No. So enter that sample information with what? What is this? You do what? Stat test. What do we say it was? Two sample what? T-test. Are you ready to enter this? Here we go. What's the first sample mean? 24.8. What's the first sample standard deviation? 3.6. Good. First sample size? 45. Okay, good. The second sample mean is what? 26.9. Is that right? With the second standard deviation is 2.6. Sample size is what? 85. Scroll down. What kind of test is this? Wasn't it a two-tailed test? Pooled is no. Pooled is no, and hit calculate. Okay? So notice what you get here. What's your test statistic? Is that negative 3.46? What is your p-value? Isn't your p-value, be careful, isn't that the same as what I have on these notes here? Test statistic. What is this? P-value. But be careful. Your test statistic is about negative 3.46, the nearest hundredths, right? The p-value is approximately 0. Why? Scientific notation. You move the decimal 4 spaces to the what? To the left. So notice what I did. I think I summarized it down here. Yes, I did. See this here? Here's your test statistic value in the notes. Okay. Negative 3.46. Where is that at on your decision rule again? Right? Negative 3.46. Oh, we didn't put the critical values. Right? This is negative 2.02. Positive 2.02. Where's the what was the test statistic? Negative 3.46. So where's that at? Isn't that to the left over here? Yep. I'm gonna erase this. What's your test statistic? Negative 3.46, I think. Okay. There and there. What is this? Reject the what? No. What does reject the no? What does that mean? Say no, you are what? Gone. What do you accept? The alternate, which happens to be the... So what do you say? Sample supports the claim. Nice. Sample supports the claim. Yes.
So it's always no on pool, right? No matter what?
Yeah.
At least for now.
for this. Well, it's going to be forever because I think there are other hypothesis tests that have pulled, but that's
And I apologize about this one, but I struggled a little bit with the last lecture on small sample means. The degree of freedom is only used to find out what the critical values are, right? It's the only.
for yeah, degree of freedom is used to find critical values. Yes, yes, and it's used for the t distribution. It's also used for other distributions. By the way, there's a lot of other distributions out there. You got the chi-square distribution, you got the F distribution. So there's other distributions, and you're going to have again degree of freedoms with those distributions. So if you take other classes in this stuff that exist, you might hear the language. Okay, now this is going to be the F distribution. This is going to be a chi-square distribution. Here's degree of freedom, and like the language of p-values. So there are other statistics classes that are out there that people take as a follow-up, and some of this language is there. You know, let's take a look at the p-value, right? If you said, what about the p-value? Well, the p-value here is what? It's approximately 0. Is that right? So if they ask you for the p-value, you might say, oh, where is that? Right here. Is it less than the level of significance? Is being broke less? This is a criteria. The answer is yes. If it's yes, what do we say you always do? That's right. You accept the alternate by the p-value. So this is another thing you can see in your life. Accept the what? Alternate. And ladies and gentlemen, isn't that what you see in the traditional method as well? So it's consistent. So I want you guys to see that because, again, there's follow-up classes that people take in statistics. And some of this stuff is there, like the language of it. But anyway, how about this? The lifespan of male Hawaiian residents is the same as the mean age of. Gosh, I got to fix some of this stuff when I get home. The lifespan of male Hawaiian residents is the same as the lifespan of female Hawaiian residents. So here's really what they're trying to say. And this is as claimed by who? By the state of Hawaii. What they really are trying to say is this, that the mean lifespan for males is the same as the mean lifespan for who? Females. Okay. So it's almost like saying the mean, here's what you want to do. The mean lifespan of females. And here's the claim. Okay. So where does that belong? Is that a null or is that an alternate? How do you know it's a null? Yep. Has a condition of equality. Is that right? What's the opposite of this? Not equal. What kind of test is this? Two-tailed. Good. So draw a picture of what? Two tails. Is that the ghost? Oh, you hit your elbow. Sorry, that was the ghost in the room. I have to say, I've never seen a ghost. I better not say that because then you'll see one. Yeah, I know. I jinxed myself. That's why you never say things, ladies and gentlemen. Never. Never. Now, be careful again, okay? You're going to need to get sample information. We're going to need to also know level of significance, right? So use the, what do they say here? Use the what? 1% level of significance to test this claim. So what does that mean? Isn't that 0.5% in each tail because there's two? Okay, and if you're awake, what goes here? Isn't this what? 99%. Do you guys know why I'm doing this? To get your critical values again, what do you guys have to use? Inverse T. Area to the left of the rightmost critical value, 99 and 0.5. That's 99 point what? 5%. This is for critical values, ladies and gentlemen. It's almost easier using the T-table. If you guys want to know the truth, I think it's easier using the T-table personally. Told you technology isn't always a blessing. So what's the first sample? A sample of 120 male Hawaiian residents. So we're trying to see about the ages of men versus women. Lifespan ages. Who lives longer? In Hawaii. 120 men. What's the average lifespan? What do you guys think? They have a mean lifespan of 78.2 years. What's the standard deviation? 5.8 years. Okay. And then you have the second sample. What's the sample size here? Sample of what? 100 female Hawaiian residents. What's their mean lifespan? 82.1 years. What's the standard deviation? That's 8.3 years. So they're going to give you the sample, the standard deviation here. It's going to be 8.3. So you might say, why are you bringing this down to the critical value area? Well, which is smaller? Do you guys know what's smaller? Isn't 100 smaller than 120? So remember, when you're using inverse T, you need to use the degree of freedom for the smallest sample size. So 100 minus 1, this is why you have what? 99. Inverse T. Okay, you guys see the point? That's the definition of it. Degree of freedom is n minus 1, where n is the smallest sample size. So now, in your calculator, you say, I need inverse T. And that's why we put 0.995. Degree of freedom is 99. And what do you guys get? 2.6 what? Is that 2.63? Okay, so look at my notes. What did I put here for critical values? 2.63 and what? Minus 2.63. So your notes verify what this is. Anyway, inverse T, it's probably the hardest one to do, but whatever. Area to the left of the rightmost critical value. Boy. Okay. Now, remember, we got sample information anyway. And what do you guys do now with some of these here? You're going to put this in. What is it? What is the function now? What's the command? It's a 2-sample t-test. So I placed them all in the TI here. 2-sample t-test. I placed it. So if you guys want me to do that here, we can. Okay? Because I think some people like that, right? Stat. Can you guys just read this, by the way, in the notes? 2-sample t-test. What do we enter? What's the sample mean? First one. 78.2. Is that right? Okay. What's the standard deviation? 5.8. What's the sample size? 120. 82.1. Sample standard deviation, 8.3. That sample size is 100? Is this a two-tailed test? Yes, pooled is no, always no there. And what do you guys get now for your test statistic value? Negative 3.96? What's your p-value? See this? Yeah, here we go. Test statistics what? Here. What's the p-value? Here. Negative 3.96 and 1 point. It's actually approximately 0 here. So I wrote that down, negative 3.96. If you want, you can either look at this picture or look at the original one. And I didn't put the critical values, okay, but I can put them just to be consistent. So 3.96, isn't that somewhere over here? Is that what the test statistic value was? Is that in the, isn't it to the left of negative 2? What's the conclusion? Good. So if you reject the null, you're accepting the alternate. What does that mean about the claim? Sample does not support the claim. What about the p-value method? What do you guys know? Wasn't p approximately 0? Is that smaller than the level of significance? Here's my p-value. Wasn't that the level of significance? Isn't this a true statement we talked about last time? What does that true statement mean? Because being broke is less than a penny. You automatically accept the what? The alternate hypothesis. So, ladies and gentlemen, automatically accept it. Let's see. Isn't that what you're seeing right in here? Same conclusion? So let me share something with you guys here. I know we're out of time. Let me do it really quick because you're going to want to care. Let me share you guys here, okay?